In this video, we're going to learn how to leverage Bigeye Virtual Tables to extend our anomaly detection onto beyond just tables and views within your data sources. So we have some dummy e-commerce data loaded here. It comes from our Postgres transactional database and is replicated across to our data warehouse. Now there's two main use cases for virtual tables. In the first use case that we're going to talk about, we primarily want to extend our anomaly detection to track certain KPIs and metrics that are beyond in our tables and views. Maybe they're not materialized permanently. Maybe it's a query that you run in your BI tool, in your spreadsheet, or something else altogether. So the way the process works is we go to custom monitoring. You see, you have two tables connected here already. So we're going to jump into our state level analytics table. I'll hit edit here. So when we're creating a new virtual table, we're giving it a friendly name. We're defining the SQL query that helps us track whatever KPI we want to put anomaly detection on. So in this case, I want to track the sum of price per unit times quantity as total sales per state, as well as the shipping state, so I can deploy dimensional level analysis on it as well. This is the table I'm going to pull from, and then grouping by shipping state. So I'll go ahead and hit save here, and when I click on state level analytics, you'll see it shows up in my data warehouse as if it was just another table. You'll see the delineation virtual here. From here, you're able to do really anything you can do with a Bigeye index table. For example, we can deploy metrics on it. We can look at a preview of this table. We can map this lineage out if we wish to. And we can also take a look at the schema changes for this table as well. Now in this case, because I have not deployed any changes, there are no schema changes to show you. So this is for the first use case of virtual tables. Again, anything you want to put anomaly detection on, but does not materialized in a table or a view within your data sources. Now let's go back to our second use case. Our second use case allows us to query any metadata that might be available in your database or your data warehouse. So anything that sits in your information schema or any SQL addressable table. In our case, let's say we want to track the history of Snowflake tasks. So I'll go ahead and hit edit on this table. You see I have a very simple query here. It just says pull from Snowflake's information schema, task history table, and I want to be able to track transformation task. And I'll order it by schedule time so that I can get most recent results first. I'll go ahead and hit save here and click on the table. Again, all the columns that you would normally be showing up in your task history show up here, and you're able to leverage any of our auto metrics, any custom metrics, and treat this like any other table. And now I can deploy metrics to make sure that task is running properly, that there's not too many failures, or any sort of other anomaly detection that you want to put on it. So in conclusion, our virtual tables are SQL definitions. They can be inputted directly into our UI. They can be inputted via API as well. And you can do with them you can leverage any Bigeye functionality on them as you would any other table or view in your system. And they help you do things like custom metrics, custom KPIs you want to track, anything not materialized, as well as anything that you can pull from within an information schema of a database.